Good evening, guys. Today we will do integration. Okay, we will start with some basic rules and then we move on to application of integration. Alright, integration is a reverse process of differentiation. Okay, when you are given y, okay, when you differentiate you get dy dx or f prime. Okay, so integration is a reverse process. You integrate dy dx or f prime, you get back the function. That's the idea. Okay. Now first rule is we're going to learn, if you are given a function like this axn, okay, they like this, how to integrate this. Plus c, this is the formula. First rule. Okay. You will always plus a c there. Okay, later I will tell you what is this c and some other type of integration. Now if I give you 10x dx, then there's a 1 here. 1 plus 1 is 2, so I'm just, to follow the formula, I make it a little bit slow, so this one is 2. You can straight away write 2 if you want, and see, this is the answer. Let the c be there. Okay, now integration basically integration can be divided into two types. One is indefinite, the other one is definite. Indefinite integration is the one with you will plus c. A definite integration, no plus c, you don't plus c. Basically indefinite integration is an integration whereby you will see like a for example like this, and if you do this you will get some expression, you will plus c. Okay, definite integration, you will have a number here like 3 2. You will have a number here, and I will teach you later how to get this one. For example, okay, there's will be a number, and you will end up with a number digit. You will end up with a constant number here. Any what do you call real number. So indefinite integration is like this. You won't have a number here. We call that as a limit. Okay, you won't have a number here. You will have an expression, and you will plus c here. For definite integration is like this. For example, definite integration, I'm taking the same function here. I put a number here 3 2. Okay, you do like a normal thing, but you will put for definite integration, you put a bracket here, put 3 and 2 here, replace the 3 inside here. Okay, replace the 3 inside here. And then replace the 1 inside here, always minus, you replace the 1 inside there. You will end up with 40. Okay, that is answer 40. So that is regarding, this is what I call definite integration. You will end up with a number, real number. Okay, indefinite integration, you will end up with plus c, an expression and plus c. Okay, that's the thing you type. plus c. Okay, that is regarding the first rule. Second rule is this type of function whereby this is linear. Linear means power 1. Okay, x must be power 1. Okay, this if you end up with, if you have a function like this, you cannot use this one. This is power 2. Cannot. Must be power 1, then only you can use this rule. What is the answer for this one? This is the answer. For example, if I want to do 2x plus 3 4 dx, how I can write 2x plus 3, 5 here, 2 here, 5 here, plus c. This is the answer. You can leave the answer like this. Square cube root, cube root we can write it as power 1 over 3, and if you bring with the power, you can bring up here. This is all basic algebraic method you guys have learned in the school. It's nothing to do with integration, just changing the algebraic. Now we can apply the rule. Negative 1 over 3 plus 1, you get 2 over 3. Plus c. And if you do some computation, this is the answer. You want to do this square root, you can write it as 1 over 2. Now you can apply the formula. That is the answer for C. D, if you notice here, all the way you can see the power is 1. If I go back to this one, you can see the power is 1, all linear, always linear, power 1, power 1, and power is 1. This is the answer for D, and for E, now we are going for definite integration. For this type of function, for this type of things, you actually can take out the 1 over 2. You can take out the 1 over 2, like this, or you can keep the 1 over 2 inside. Okay. If you replace inside here, as I told you, you replace 39 and 0 inside here. Answer, you will get 221 over 2. Third one, if you notice that this is non-linear, okay, this is non-linear means any function x more than power 1, okay, like x square, x cube, something like that. Okay, inside here, if you notice, if you differentiate, that expression is outside here, then you can write it as the answer is this is the thing. Some of you might not understand what I'm doing here. Okay, I repeat, the one inside the bracket, the one having power here, the one inside the bracket, you differentiate. When you differentiate and you find out that is outside here, then you just simply can write the answer like this. So to show one example here, okay, to show one example here, what is the fx here now? Okay, fx is the one inside the bracket here. This is the fx, huh? So my fx, this is my fx. I'm going to, this is my fx. If I differentiate this, what I get? Okay, negative 3x square. Is this outside here? You can see here it's outside here. So what is the answer according to the rule? Take the fx plus 1 to the 1 over 2, which is plus 1 this one. Okay, I go a little bit slow. This is the answer. You can simplify this one. This is the answer. For B, you can see here this is non-linear, the one inside the bracket here. This one is x to the power of 3. Yeah? Okay. Now this one, what is my fx here? This one. This is inside here. You can see this is outside. So according to the rule, negative 1 over 2 plus 1 become 1 over 2 over 1 over 2 plus c. Over 2. You can leave the answer like this, but is the 1 over 2 we know is a square root, so this is much nicer to see. So I just leave it like this. Okay. Now I'm going to take the same function, a little bit different. Just now the function is 4x 2x square minus 4 negative 1 over 2 dx. Now instead of 4 here, let me put 2 here. Okay, instead of 4 here, let me put 2 here. Now what is my fx here? This is my fx. What is my f prime? 4x. Is the 4x here? No. The 4x is not here. Okay. You see, here we need 4x. Here only 2x. Okay, only the coefficient differ, but the variable x and x are there. So we can do some adjustment. We call that is adjustment. What adjustment we can do? You take out the 2. These 2 here, you take out. Take out. When you take out coefficient, you can take out. Put x here. Okay, like this. So just now how much, what you want? You want 4. So multiply 4 here and then do the adjustment. Whatever you multiply here, you divide here. so that it becomes it goes back to the original. So we have to do this kind of whatever is multiply. If you don't understand, just listen to me. You multiply here, whatever value you multiply here, you divide here that value. Okay, now this is 1 over 2. Now you can apply the rule. According to the rule, if fx is here, you differentiate, it's outside here. Now you can apply the rule. What is the rule? This is the rule. You can cancel this. So the answer is D. We're going to do a definite integral. Going to rearrange. This is your fx. The fx is always the one with the power. F prime would be 3x square 1. Is this here? Yes. So the answer is 10. Now you don't need to plus c because it's a definite. You put 1 and 0 here. And if you do this, if you replace 1 inside there, it becomes if you replace 1 inside here, becomes 210 minus 0, because replace 0 becomes the whole thing becomes 0. You can leave the answer like this because it's going to give a big number. You put in a calculator, or not so big. So this one is, you can leave it like this. This is my fx. I hope still remember how to integrate, differentiate ex. Recall back. If you differentiate this, we get 0 there, and 2e to x. We want this one. Is it here? The variable is there. Variable is there, so that is a good sign actually. Variable is there. e2x is there. Only the coefficient I have to change, isn't it? So what I need, I multiply here by 2, but I divide here by 2. That's what I call adjustment. Bring the 1 over 2 here. Now we can apply the formula. this is the answer. Alright, next. Next rule, this rule was rule number 3. Rule number 4. Remember, this one is linear. When you integrate linear, then E this is the answer. If you integrate EX, basically the answer is EX. So you differentiate EX also, answer is EX. You integrate also, the answer is EX. According to the formula, divide by the A. The A here is this 184. If you have to expand this, you can either write this 2 times and expand one by one, or I normally use a shortcut. Like this. So if you expand this, now is separated, no more in the bracket, so we can use the formula now. This one integrate as normal, okay, polynomial. If you see a number, you just put an x here for polynomial. If for differentiation, if you see a number, it becomes, if you differentiate, it becomes 0. For integration, if you see a number, you integrate, you add, you multiply an x there. Okay. You can leave the answer like this, or you want to simplify like this also. Okay. Square root is I can write it 1 over 2 there. So you bring this one up. Now we can use the rule. Next rule. Sorry, this is not E, this is next rule. Rule 5. This one is non-linear. Non-linear means x more than power 1. If you see this, then the formula is just, okay, if you see the f and you differentiate that f, if it is in front of the function, then you just write like this. Let me show you an example here. What is my fx? This is my fx. Fx is x square, f prime is 2x. Is the 2x is here. So whenever you differentiate, it is in front here. Then you just write back only this one and put a c here. What is my fx? This is my fx. If I differentiate this, I get 4x cube. Is the 4x cube is here? No. X cube is there and x cube is there, that is fine, that is good. Okay, we variable is there, is okay. Okay, let's say x cube here and x square here, then we cannot do anything. You cannot multiply with x. Don't multiply the variable. Only constant can be multiply and divide. Variable you cannot divide. If x square here, then we cannot use this rule. Okay, now we have x cube here. Okay, no problem. Only constant is disturbing us, so multiply here 4, divide here by 1 over 4, and you can use the formula. This is my fx. F prime is 3. The 3 is here. So according to the rule, write back 3x e 3x plus c, but this is definite integral. Definite integral, you put a bracket 1 0, replace the 1, you get e to the 3, replace the 0 there, it becomes e0. Any number raised to the power of 0 is 1. You can leave the answer like this, or you can press the calculator. You will get 19.08. That is the answer. Now number 6. I think this is the last one, but anyway, we'll check. No, this is not the last one. There's another one. If you see a function like this is linear. If you see a linear function like this, what you do, take ln ax plus b divide by a. See, example, this is a linear, so I can write it ln 4x plus 5 over 4 plus c. That is the answer. You can leave the answer like this. Ln 2 minus 5x, the a is here is negative 5 plus c. Can leave the answer like this, or negative 1 over 5 ln plus, we can also do this. For example, we just to let's say the question is now 7 over 2 5x, then you can still do, okay. Just constant means only numbers, right? Just a number, not a variable. You can take out the 7, and then you will end up with the answer like this. So this is negative 7 over 5 ln 2. This is the answer. So still can, okay, don't worry. If the numerator is just a number, we can still can do. Variable, then we have to use some other method. You can take out the 1 over 2, or you can keep the 1 over 2. In this case, I want to take out. So if you replace 5 inside there, you will get 2 times 5. This is ln 9 minus, put here ln 1, and if you notice this, ln 1, if you press the calculator, is 0. So answer is 1 over 2 ln 9. You can leave it like this, or you can press the calculator, it gives me a decimal number. I think that's the last one, rule 7. Okay, this is non-linear, this one is non-linear. Just now linear, isn't it? This one is non-linear. If you differentiate f and it is in the numerator, then the answer is ln fx plus c. That's it. For example, my fx is this one. If you differentiate this, you get 4x. This one is here, okay, no need to do any adjustment, nothing is there. So the answer is plus c. That is the answer. This one is here, okay, no adjustment is needed, all perfect. So what you can do, ln according to the rule, you don't need to plus c here because it's a definite integral. 1 0, you put 1 inside there, you will get 2, you will put 0 inside there, you get 3, and according to the ln rule, you can leave the answer like this. Okay, I leave it, you can leave the answer like this, or according to the ln rule, minus means it will become 2/3. You can leave the answer like this. This one also I accept, this one also I accept, or if you want to press in calculator, give me decimal also can. Now last one, C here. This is my fx. Prime is this one. Is this here? X cube is there. Okay, x cube is there. So all I need to do is I need to multiply the whole thing with 4 and divide with 4. If I do that, am I getting 4x cube and plus 8? Otherwise, if I don't get that, then I cannot use this formula. Let us check. 4x cube getting that. This is the formula, this is the answer. Okay, just hold on, need to check certain things. alright, that is regarding the basic, all the basic rule. Okay, so if you later I'll share with you the tutorial and also full answer, complete answer, how to do each and every question there. Okay, these are the basic. Now we are moving to application. For application, I need to see the slide now. So in differentiation we have seen what is marginal, how to get the marginal profit, marginal cost, marginal revenue. We differentiate, isn't it? Now reverse, they give you marginal and you get back the function, so we have to integrate. As I told you just now, integration is a reverse process. Okay, so as I told you just now, in this example, this is example 1, basically example 1. If given P, I want marginal, I differentiate. If P prime, I want to get back the P, I integrate. So they have given you the P prime now. Okay, if the marginal profit for producing X unit per day is given blah blah blah, find the profit function. This is the profit function actually. Okay, so let us do this. You integrate. We want to find Px, profit function. So we integrate Px, I mean P prime. As I told you, any number you want to integrate, you multiply an x, the variable. So this one will give you this is the function, but there's a c there. Okay, there's a c. For we have to find the c. Sometimes they give you what do you call the hint. The hint they have given here is P is 0. When you replace x equal to 0, the whole thing is 0. So when you replace x equal to 0, the whole thing is 0. So c is equal to 0. So we found the c already, and rewrite back the function. We found the function. This is the profit function. Now what they want? We found the profit function, and they want the profit when x equal to 10. So when x equal to 10, press in the calculator, the profit is dollars, 999. That's how you answer example 1. Now example 2. A company manufactures X TV per month. The monthly marginal profit, again a profit, currently manufacturing 1,500 per month, but is planning to increase the production. Find the change in the monthly profit if the monthly production is increased to, okay. So first of all, what we have to do, we have to find the profit function. Okay, let us find the profit function. This is the profit function in terms of C. Yeah? So they want the change in the monthly profit if the production is increased. So before increase, which is the current, they produce 1500. With 1500, how much is the profit? This is the value. If 1600, what is the profit? Plus C. This is the profit. So when we minus, we want to see what is the change. We will get $1,000 increment. That's how we do. So basically, again, we have to find the profit function, and this is how we answer example 2. Example 3 now. The market research department of a supermarket chain has determined that for one store, the marginal price, this is price demand P, of X tube per week is given there. Find the price demand equation if the weekly demand when, okay. So again, we want to find the price demand equation you can bring this number outside, or you want to keep inside also can, because the one I'm going to integrate only this one. This is just a coefficient. This is the price demand equation, and we have to find the C here. They did give you some clue here. When x equal to 50, the price is 4.35. So when x equal to 50, the px is, so replace inside there. You get 3.44. Okay, so you rewrite again the P. That is the marginal function. Okay, we found the marginal function. Now find the weekly demand when the price of find when px is $3.89, what is the x? If you want to solve this, you have to use ln both sides. Ln e will cancel each other. The left is 1, then x is approximately 120 tubes. That's the answer. Example 4 now. Typing rate. Okay, an average student enrolled in a typing class progress at a rate words per minute. Okay, so the n is actually words per minute, number of word you type in a minute per minute. T is a week. How many words? If a student could type 25 words per minute at the beginning of the course, how many words per minute would the student be expected to type t weeks in the course? Okay, so this is a 15-week course. The formula, the n is actually after 1 week course, how many words the student can type in 1 minute. After 2 week, then we can compute how many word the student can type in 1 minute. Okay, basically we need to find the n first. they give you we have to find the C, and they give you the clue here that a student could type 25 word. So n is equal to 25 at the beginning of the course. Beginning of the course is t equal to 0. So when t equal to 0, n is equal to 25. So the answer is, you rewrite back this one. This is the function for number of word they can type in 1 minute after t weeks. After t weeks, maximum week is 15 weeks only. Okay, after completing the square. Okay, words per minute. We have to now for B. Just now was A. So after completing the course means after 15 weeks. Basically here you have to write 15. T equal to 15. Press this 79.38, almost 79 words. So after completing the course, the candidate can type 79 words per minute. So it is keep on increasing. Okay, that is number 4. Last one, number 5, example 5. An amusement company maintain records for each video game installed in arcade. Suppose C, T and RT represent then cost and revenue. T years after particular game has been installed. Okay. Find the useful life of game to the nearest year. So what is useful life of game is when C prime T is equal to R prime T. C prime T is 2, R prime T is 9. So basically we need to solve this. And T is equal to 3.008, approximately 3 years. Okay, so the useful life, okay, that the value of T, the useful life is 3 years. Okay, for B now, Find the total profit accumulated during the useful life of game. So profit is what actually? Profit is revenue minus cost, that is profit. So we have to find what is the revenue function now. Or we can also do like this, either profit equal to revenue minus cost. Profit is equal to revenue minus cost. We can do separately one by one. Now in this case we have to use another idea whereby if we integrate profit, basically we are integrating, when we differentiate profit, basically we are differentiating revenue and also cost. And let us find the marginal profit function first. This is 9 minus 2, so that is marginal profit function. Now once we get the marginal profit function, we find the profit function. This is the profit function. Now when we want to find the total profit accumulated during the useful life of game. So when t is equal to 0, t equal to 3, useful life just now was 3, isn't it? Okay. When t is equal to 3, what is profit? They want accumulated, profit accumulated, so we have to find when t is equal to 0 also, and from there we have to minus. When you will get negative 18 plus c. Okay, so what you do now, P3 minus P0, that is the accumulated profit. 7.98, that is the accumulated profit. So this is how you have to do on example 5. There are many exercise in tutorial, you guys try first. I have given full answer, you can look at the full working. If you don't understand, you can WhatsApp me. Okay, with that we finish integration, alright, and try to do all the tutorial. With that, that's all for today. I'll see you guys in our next class. Take care.